Hello guys, Victor White here. Welcome back to another Leetcode video, and today we'll be doing the container with most water question. This question says you are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are this and this, right? Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So what this means is you are given an array of numbers, and each number in the array represents a certain line on the graph. The question is, what is the maximum area that can be achieved from um from that from this array, right? When imagine you're pouring water into this, so what's the maximum area that can be achieved here? So from looking at this, we can know that a way we can calculate array is always like rather area is length times breadth, or in this case, it's going to be length times the height, right? So the height of this, the minimum of this, because anything that exceeds this will like technically spill over, right? While the length will just pretty much be the subtraction of the indices of this. So if the index here is 8 and this one is 1, 8 minus 1 will give you 7, and times that by the highest, which is here 7. 7 times 7, 49. So that's how they got 49 as an output. So let's first think of a brute force approach to this, right? How do we solve this using a brute force approach? So the first thing that we can do is to have two for loops, right? The first pointer is going to be pointing to this one, and a second pointer will point to this one, right? You will then calculate the array, the area of this, move on to the next one, next one, next one, next one, right? Until you have iterated through the array. After that, you update the second pointer to the next one and do the whole thing again, right? So let's quickly code that out and see how that will look. So first, we will just initialize our max area right now, and we just put that at 0. Then we'll go into our first for loop. So here, initialize p1 to 0. So that's going to start off at the first element in the array. While is less than height dot length, right? p1 plus plus. So because to calculate the area, you would need p1 and p2, right? You need the values of p1 and p2 to be able to calculate the area. So you go straight into the second for loop, where we are going to initialize p2 to be p1 plus 1, which is just going to be the next element. So for a start, p1 will be this, p2 will be this, right? So why p2 is still less than the height of length, which is the length of the array, right? p2 will be incremented by 1. So now let's get our values that will be used to calculate the area. So the height would pretty much be the minimum of these values. So this one here is 8, this is 7. The minimum of that will be the height, because anything more than this will, like I said previously, technically spill over the container, right? So we're going to use the math.main and get the height of p1 and the height of p2. Then the width will simply be the subtraction of the indices, which is p2 minus p1. So that the area now becomes the height. Okay, let's just call it, since this height is already what's being called here. So let's just give it maybe h and w, just so that it wouldn't conflict the variable names. Obviously, if you have a better way to name that, that's fine as well, that work, right? So the area is the height times the width, right? So then the max area becomes the max of whatever area and also the current max area, right? So once it has gone through the array, it's going to keep updating the max area to the maximum of whatever array is being calculated at that current iteration, and the current max area value. So afterwards, you just simply return your max area at this point. So if you do a quick walkthrough, the first time here, P1 would be 0. And because P1 is 0, P1 at this point would be 0. And here, P2, right, will be 1. So at this point, H, the height, will now be the minimum of the minimum between the height of P1 and the height of P2. So the height of P1, this is going to be 1 and 8, right? So here would know that this H here at this point will be 8, and here the width would be P2 minus P1, which is 1, because it's going to be 1 minus 0, which would then be equals to 1. And the area at this point will now be 8 times 1, which is going to be 8. The max area would then be updated to 8, because it's greater than 0, so it's going to now be updated to 8, right? So that would repeat itself until you get here to this case, right? These two red bars here. Let's quickly just do a walkthrough of that one so you'd understand the brute force approach. So at that point, right, P1 would be 1. At that point, P1 will be 1. P2 would be 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Height would be the minimum of the height of P1 and height of P2. The height of P1 here is 8 and P2 is 7. So the minimum of that will be 7, right? Then the width of that would be 8 minus 1. So the width here would be 7. Then the area would be 7 times 7, 7 times 7, which will then be 49. And at this point, max area becomes 49. So once you go through the array, or once it iterates through the array and runs through this function, right, whatever the max area would be, it would return it, and that would be your answer, right? So if you look at the time and space complexity of this, simply looking at the fact that you have two for loops, the time complexity is simply going to be of n square, so this is going to be O of n square time, where is raised to power for the time. Then the space of complexity, because you aren't using multiple, you are not, there is no scaling space here. You are pretty much just updating this max area and this P1 and P2, which is also just getting updated and all of that. So the space complexity simply is of 1. All right? So this is a brute force approach to this algorithm. And now we'll move on to the optimal solution. So for the optimal solution, we'll be using a technique called the shifting two pointer. Here we will put P1 is going to remain, is going to start at the first elements in the array, while P2 will take this last element in the array. We will then calculate the area, then set the max area to the maximum of what the area of that calculation is and the current max area at that time, right? Like we did on the brute force approach. But the only difference now is we will either shift P1 or P2 depending on the lesser of the two. Because if you look at our calculation for max area for the area, right, is the minimum of the heights of the two values, right? So it's that height that impacts the area more. So we will then shift in the P1 or P2 depending on which one is greater than the other. So let's just quickly code that out now. Just delete all of this. So here we are going to be initializing a couple of things. We're going to be initializing P1 to be 0, P2 is going to be the last element there, which is this minus 1 because of the 0 indexing, right? So we have to subtract 1 from it. And then we're going to initialize max area as well to 0 like before, right? So here we're going to say while P1, and I'm going to explain why in a bit, while P1 is less than P2. And this is because, like I said, we're going to either be shifting P1 or P2 in. So while P1 is still less than P2, then you can do the calculation and this while loop will run. But immediately P1 is either equals to P2 or greater than it, then the while loops break and then you get your result, because technically you would just be recomputing it again if you keep going like that, right? So this is the condition to break this while loop, and then we would calculate our height again to be the max dot min of those values like before, P1 P2, and our width again like before is going to be the subtraction of those indices, right? And the area will simply just be the height times the width. Then we'll set our max area to be the max of the area that was just calculated and the max area, the current max area rather. Can't type today for some reason, max area. Now this is where things get a bit tricky. So now if the height of P1 is less than or equals to the height, this is just heights, the way to name this variable, of P2, then it's going to be P1 plus plus. If if P1 is less than P2, the height of P1 is less than the height of P2, then you move P1 in, so you're going to increase P1 by 1, right? Else you are then going to move P2 in, so it's going to be P2 minus minus, right? So look, if we just at the end, we of course want to return max area, so you can give us a value. So if you do a quick walkthrough of this, so at this point P1 at the first iteration, right, P1 will be 0 normally, 0. P2 will be height dot length minus 1. So the array 1 2 3 4 5 6 7 8 9, so the length is 9 minus 1 is going to be 8 to give you the last element in the array. So this P2 is going to be 8. Max area at this point is going to be 0, right? So here, the minimum of the values, H is then going to be, so the height of P1 here is 1, 7, minimum of that is 1. The width is going to be 8 minus 0, which is going to be 8. And the area will be 8. So then here, max area is then going to be updated to 8. Then going to be updated to 8. So at this point, because the height at P1, which is going to be 1, is actually less than the height at P2, which is going to be 7, P1 is going to be updated to 1. So it's going to move to this next bar, right? Because this condition would be true. But if we run this while loop runs now the second time, and then we calculate the area. Let's do that walkthrough, right? So at this second time, P1 will now be 1, right? But P2 is going to stay at 8 because it was P1 that moved in. So now the height is going to be the minimum of the height of P1 and the height of P2. So the height of P1 here is going to be 8, and P2 is going to be 7. The minimum of that is 7. And the width is going to be 8, right, minus 1, which is going to be 7. And then the area is going to be 7 times 7, which will give you 49. 7 times 7, which is going to give you 49, right? So then the max area gets updated to 49. right? And obviously, it will still technically run through the whole thing until this condition gets triggered, and afterwards, you'd return your max area. So this is the optimal solution. And obviously you can see from this, we don't have two for loops, it's just going to be one iteration. And because it's going to be one iteration, our time complexity then becomes of n. So technically you worst case scenario is going to be touching every element in the array. So our time complexity becomes of n, and our space complexity stays of one, because you're only going to be updating variables. There's no scaling space of any sort. So it's just going to be O of one. So if you quickly just run this, make sure we're not making any errors. Okay, so it's the two cases it tested it against was correct. So if you just submit it to see if it's going to hold for other test cases, you see that it does hold for other test cases. So hopefully this helped someone out there. Thank you for watching. If you enjoyed this, subscribe and like the video. Leave a comment, telling me what you think, if there are better ways to do this, and I'm open to criticism as well. Thank you. See you in the next one. Goodbye.